And our next speaker is Paweł Świeboda. I hope I'm pronouncing that correctly, Director General of the Human Brains Project and EBRAINS for advancing neuroscience and brain-related medicine. So it's one of 3 future and emerging technology flagship projects that started in 2013 and is one of the largest research projects in the world. More than 500 scientists and engineers at over more than 140 universities, teaching hospitals and research centres across Europe. So it's quite some project. Thank you very much, Pavel, for being with us. We're looking forward to your contribution now. Thank you.
Thank you very much, Deidre. I hope my early morning Irish name pronunciation course
you did excellent.
delivered a decent result. So thank you so much for having me. Also, great thanks to Alzheimer Europe and Charité. I'm truly delighted to be here with you today. Let me just share my screen if that's possible. Yes, very good. So as Petra Ritter already gave us a deep dive into the technology of the virtual brain, I think no one has any remaining doubt that digital data holds really the best promise of enabling breakthroughs in diagnostics and therapeutics of dementia. And we owe it collectively to the patients and the communities concerned to make sure that the remaining barriers to responsible sharing of data are overcome. There is a sense in the community that we need a step change in how data is used. In particular, I would say it's imperative to ensure that the benefit of scale is gained from large data sets to enable algorithmic insights and pattern recognition. It is equally important that data is used responsibly. GDPR, and we received from Petra a short legal course on the GDPR, is the law of the land and should be used as an enabler rather than a wall behind which silos are preserved. I know it's easier said than done, but I will demonstrate in a second how some of our solutions are being GDPR compliant and moving the needle at the same time. Finally, researchers and clinicians need to have the state-of-the-art tools to work with data through improved findability and sharing. In my presentation, I would like to make 5 points. Firstly, that collaboration is key to working with complex data sets. Secondly, that amplification is needed to assist data users and enable them to reach results. Thirdly, that principles of responsible use and privacy have to be built into the design of data sharing systems. Fourthly, the Human Brain Project and EBRAINS are ready to work more closely than ever with the dementia community to support its efforts. And fifthly, scale is of essence. And the brain health data space is urgently needed as part of the European health data space, the flagship project that the European Commission is launching for 2021. Because this can provide us a unique opportunity to overcome silos and achieve the effect of scale. At the Human Brain Project and EBRAINS, data is at the center of our twin goals. And I say twin goals because we have sort of 2 sides to the coin. One is the scientific work program, and the other one is the ongoing development of the research infrastructure for brain studies. Human Brain Project is an EU flagship dedicated to understanding and computing the brain. EBRAINS is the research infrastructure and a platform for research projects that will continue when the Human Brain Project is completed in 2023. We also aim to join the European Forum on the European Strategy Forum on Research Infrastructures, the S3 roadmap in 2021. Let me say a few words about our scientific focus in the next 2 years. And it is firmly on decoding brain connectivity, from examining the human multi-scale brain connectome and its variability, through networks of cognition and consciousness, onto networks for adaptive architectures for cognitive functions. Some of the achievements include the largest ever 3D reconstruction at high resolution of the hippocampus, allowing the examination of fiber architectures. The HBP has been particularly impactful with regards to high density data, meaning one with higher spatial or temporal resolution. And it is this type of data that helps to decode complexity and is necessary to understand the emergence of conditions such as dementia. Petra has just presented in an extremely eloquent way how our scientific work on the human multiscale brain connectome and its variability can contribute to progress in personalized and precision medicine for brain diseases. This is one of our key roles to play, apart from helping to advance neuroscience and ensuring technological progress in brain-inspired computing in particular. So our aim is for these multi-scale models developed in the EHBP to help identify subcategories of neurodegenerative disorders and probe innovative pharmacological interventions. Large-scale cross-disciplinary collaboration is absolutely key to drawing benefits from the data, as we have seen ourselves in the HBP, which is, by the way, a spacious tent. We have teams of neuroscientists and clinicians working side by side with software engineers and AI experts. And this sort of feeds into a new culture of scientific discovery that we would really like to continue also beyond the HBP. My second point today is about amplification and the need for amplification. So data sets are only useful if one can establish a meaningful way of drawing results from them. The services that EBRAINS provides are all about the researcher's ease of working with the data. They range from online solutions to facilitate sharing and access, computational models and software through the brain atlases that enable users to analyze information on the basis of anatomical location. They also provide and include simulation tools and the medical informatics platform, and I'll come back to the latter in a second. The levels of findability and federated data analytics on EBRAINS often exceed what is offered elsewhere in brain research. The HBP's work to date has resulted in a growing treasure trove of data that is unique, that is high quality and well curated using the EBRAINS knowledge graph and accessible to the international research community, which is of course crucial. This achievement is unique in many respects through multi-scale and multi-level approach, but also the impact of sharing resulting experimental data and helping collaborations. Our data knowledge services are built around a graph, which gives more flexibility. The experience is meant to be as user-friendly as possible. And you are watching right now the ebrains.eu portal and how you can operate through that ecosystem. We are currently offering a new version of the knowledge graph integrated with Open Minds, the initiative offering metadata models, and that results in much smarter access. We also put at the disposal of researchers workflows to support the use of tools and resources such as the atlases. We offer tutorials and high-level support. So this makes it for an entire eBrains experience, one could say. And what sets eBrains apart is that tools and services are designed and built under the guidance of researchers themselves. This has allowed us to learn a lot about how to encourage collaborations between groups with very different backgrounds. And we are aligning standards now with EOSC, looking forward to full integration. The goal here is to implant in practice the concept of fair data. The challenge for neuroscience in this field is significant, considering that the different research communities and sub-communities, which often have their own methods and technologies, have developed their own standards and data formats. So there is no doubt that the fair data approach is time and labor intensive. Not only do many tricky computing questions have to be resolved, to bring the different types of data under one roof, But researchers also have to be convinced to devote a significant amount of their time to preparing the data in such a way that others can also make good use of it. So mindset of collaboration is essential. In the course of last year, COVID-related research moved the needle decisively for open science. OECD has done some work on this and has shown that up to 75% of the 75,000 scientific papers published by November last year were open access. I mean, this is a revolution. This now has to be the new normal also in brain research. It will not happen by itself. Collaboration has to be factored into the equation by different ways, for example, by being reflected in the ways we measure success. My third point is that GDPR compliant solutions offer perfectly viable research results. Of course, the GDPR is a massive challenge. I think after Petra's introduction, we have no doubt about that. But our platforms are built and operated with strong privacy data measures, data protection measures, governing storage, governing computation, and extraction of data. So the data sets we work with are mostly anonymized data. We have a new service released literally 2 weeks ago for protected, de-identified, pseudonymized data. It's called the EBRAINS Human Data Gateway. And we are working on solutions for sharing other types of personal data, including other types of pseudonymized data that I not mentioned. One of the GDPR compliant solutions is provided by our medical informatics platform, an interoperable platform for federated data processing and analytics. So what is the MIP? The MIP is an ICT solution which allows researchers to apply queries to anonymize patient data drawn from a large number of hospitals across Europe, currently over 30. Such technology helps to better understand commonalities and differences in neurodegenerative diseases. It is open source, easy to install software, connecting hospitals or research centers, and opens new channels of collaboration, including in international consortia. The merit of this approach is that it is the least invasive way to connect hospitals and data sets. It is built on the understanding that there is no need to centralize data to provide significant value when it comes to aggregate findings. The platform is attractive for a range of stakeholders. You can see them listed here, from data owners, clinical scientists, clinicians, on to data scientists in medicine and brain diseases. Data owners have full control of accessibility and federation of the data through a tightly controlled system of accreditation, access, and user management. So the MIP enables federating data sets to test biomarkers and predictive models in real clinical settings, arrive at new findings by increasing the sample size of research cohorts, for example, and also provide detailed information on existing cohorts. There is one important work on dementia taking place on the MIP right now, which I would like to share with you, not in detail, but just in a nutshell. And it concerns federating data sets with clinical, neuropsychological, MRI, and biological data from a public research cohort of reference, ADNI, and 3 independent real-world clinical data sets. What the approach has enabled is testing the AD biomarkers and their comparison, leading to a clear separation of 3 clusters of patients. I'll be happy to share more details with anyone who is interested. Now, my fourth point is that the HBP has, from the beginning, had a threefold focus on computing the brain, but also supporting brain medicine and developing brain-inspired technology. EBRAINS will take this commitment further as it continues as a research infrastructure and as a research platform after the end of the HBP in 2023. We are therefore looking actively at ways of supporting dementia-related research. We would like to do this in the future by mobilizing a designated pool of resources and tools and services from the data management and curation set that I mentioned through data sharing onto modeling and simulation. Developing the next generation of virtual brain that Petra described and presented from the perspective of better serving the needs of dementia research. That's our direction of travel, and I very much hope that this would be of significant value to the dementia research community. Now, fifthly and lastly, scale is of essence. And this year offers us an opportunity for stepping up the sharing of data in Europe with the expected launch of the European Health Data Space, aiming to ensure access and better primary and secondary use of health data in Europe, with all the relevant implications that this has for also innovation and digital health products and services. Now, brain data is an unparalleled domain where broader approaches can be tested because of its unique richness and complexity. We have enormous volumes and types of data, petabytes of data that have already been mentioned with respect to the virtual brain. So once solutions are tested in the area of brain health, they can easily be applied across the European health data space. So what we need is a brain health data space to build a sufficient scale of easily accessible, high quality data to bring about collaborative use through FAIR and HPC resources, enabling breakthroughs in diagnostics and therapeutics of brain dysfunctions. The BHDS, if I can use this acronym already, would aim to overcome the current fragmented data landscape, where honestly it is often difficult to validate results across multiple settings, not to mention the training of machine learning and AI models. Opening large and diverse samples to collaboration would lead to more robust findings and generalized evaluations. So this would be quite a game changer. The brain health data space would offer incentives to both producers and consumers of data, which is absolutely vital because you need to encourage both sides of the equation to come onto the platform. And it would do so by availability of a large range of data sets and the possibility of setting up collaborations, GDPR compliance, security and safety of data, and the high performance computing potential. Now, EBRAINS is very much ready to support this effort through the amplification offered by EBRAINS services, such as data curation, structuring and storing of data, quality control, and GDPR compliant solutions. This is an opportunity which, in my view, must be seized. And I really hope that we can join ranks to bring it about. I would like to thank you for your attention. Thank you so much.
Great, good. Thank you very much, Pavel. Thank you for all of that. I'm sure we'll be looking to analyze all those slides at a later time. But I think what your last slide there towards a European brain data space probably quite significant, and it's very interesting to see the value, the statistic used about the value of the open data space. Really interesting to see that. So thank you for your contribution, and I'm sure there'll be questions later.